guys. My name is Desmond. A very warm welcome to my lesson for today, where we will be looking at mathematics. So as you can see over there, question 3 is what we will be looking at in today's lesson. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important, because what I'm about to say is massively. Hey, massively important, ladies and gentlemen, that I say without learning something new a day. When please do make sure that by the end each every lesson that and something new, very, very important, ladies and gentlemen, over there. So in this lesson, what we are not going to do is waste our precious time. Remember, that lesson yesterday I did an introduction. So the lesson what we're doing is to do at time question papers. I need a last question. Can you and can you before I?
So you're cutting.
Guys, let me see. Just want to show. Hello, I come back. Lindy, is it better now? How about now?
Yes, sir.
Okay, 100%. So now this is what I'm going to do very quickly. I'm going to read through that statement. Remember, the question paper that we'll be doing in today's lesson is what was posted yesterday. Let me quickly try to check if I can possibly forward that again in the group. So just make sure that in this same group, you scroll up to a question paper that has that question. That's what we'll be doing in today's lesson. Very quickly, I'm just going to read through that given statement, take you through the questions. I can see it is there and it's not far. I'm just not sure whether to forward it again into the same group, but let me just quickly forward it. Yes, there it is forwarded. So this is what I'm going to do. Read through that. In the diagram, having a point A with 5 and 3, and then we've got B having 0.5, C being that point there, and E being that point there, are the vertices of a trapezium having BA. Where is B? There's BA being parallel to CE. Okay, that makes sense. D is the y-intercept of CE. Okay, there is CE, there is D, and it is the y cut or the y-intercept. And then also CE. And CD. This is CD. They say it's equals to DE. Okay, that makes sense. And also, remember, we did discuss all of that in yesterday's lesson, and I said some of you guys can still give it a try, but we'll do the answering part in today's lesson. So just in case if you missed a introduction yesterday, make sure to catch it up, because everything that I'm going to be doing is based on that lesson. So let's see. The first question, which is 3.1, it says calculate the gradient of AB. Remember, analytical geometry, a game of two things. What is the formula for calculating the gradient? We know it is small letter m, which is equals to delta y over delta x, which means it is actually y2 minus y1 over x2 minus x1. If you like, you can say y of a b minus y of a over x of b minus x of a. It doesn't really matter that much. Then you know what you do is just to substitute. So sometimes one might be wondering, how do you choose y2, y1, x2, x1? To me, I used to say alphabetically you start with A all the way up to Z. So the letter that comes first is your x1, y1. The letter that comes second, it is your x2, y2, meaning this comes second. So this is going to be my x2, y2. So let's substitute. We are having our b being a half. So you are just going to say half inside the brackets because it's a fraction. And then you say minus that one over there, which is what? Which is 3. The whole of that divided by what is my x2? Obviously, it's going to be 0 minus 5. Then what you do is just to punch all of that on a calculator. So let's see. What answer are you guys getting there? So 0.5 minus 3 over negative 5. I'm getting an answer, guys. What are you guys getting that side? I suppose the message is still delivering. Am I still breaking, guys? I wonder if you got my question.
Sir, I got a half.
Someone got a half, but am I breaking,
Same, sir.
honorable member?
No, sir.
Okay, I also got a half. So remember, for you to know that your answer is correct, obviously you expected a positive value. Why? Because of this type of a line ending in the first, and if you extend it, it ends in the third quadrant. That's how you know your answer is correct. So with a red ink, let's just write it there to say the gradient of line BA is equals to half. So I'm not sure if you guys remember, based on yesterday's lesson, we said if you have two lines which are parallel to each other, they have equal gradients. And from the statement, we were told that AB is parallel to CE. So let's also say the gradient of this line, it is also a half. I'm not sure if that makes sense to everyone, but if it doesn't, make sure to ask me why. There is a reason to every maths problem, or there is a reason to every explanation. Whatever that feels like is confusing you, let me know and I'm going to explain. So I assume everyone understood that part. And most importantly, in case if there's something that I've done of which you do not understand, make sure not to allow me to continue Whether uyathetha, uyakhuluma, noma ini, make sure that you engage and let me know where you are falling behind. And very quickly, I'll make sure that I explain. So let's see. 3.2 says, determine the equation of CE in the form y is equals to mx plus c. So they have already given you a hint that you are actually determining an equation of a straight line. And what did I say regarding determining an equation of a straight line? I said, in other words, they are simply saying, give us the m value, give us the c value, and rewrite everything in a form of x and y. Very, very much. And most importantly, analytical geometry, a game of two things. So now, do you have two things? I think we do. Number one, we know that the gradient of that line is also half. Why? Because it is parallel to that line, meaning we already have y is equals to a half x plus c. So can you see? We've already substituted the first thing that we know. Since analytical geometry is a game of two things, what is the second thing that we know? You ask yourself a question. Do I have a point on that line? I think I do. I don't have the coordinates of C, I don't have the coordinates of D, but I do have the coordinates of E. That is why you're going to say at E, where X is 6 and then Y -4. So can you see? You make use of this point to calculate the C value. Let's see. Where we see Y, we're going to substitute that, meaning -4 is equals to a half into X, obviously 6 plus C. What exactly are we trying to do? We are trying to calculate the C value. So it's more like you're having -4, which is, what is half of 6? Is it not 3 plus C? Okay, so let's see. You take that to the other side, and then it becomes -7 equals to C. So now we have already calculated the C value, meaning equation of a straight line equals a half x minus 7. Someone who has been attending my lessons realized that, okay, that means this point where we already know that something is 0 being 1, y is 0 at that point because it is the y-intercept. We just calculated the c value, which means that straight line which was originally passing from the origin has shifted by 7 units downwards. That is why it cuts the y-axis at where y is equals to -7. So that's you answering this question. And I'm telling you, with you doing that, they will give you full 3 marks. Anyone who's got a question before we move on to the next question?
So can you repeat y is equals to 1 over 2?
Matapelo, which one to be repeated, honorable member?
Y is equals to 1 over 2x plus c at e into 6 dots into.
Okay, maybe don't mute your mic, honorable member. Aritshebe baskare kwanene. Aritshebe Matapelo. Okay, let's see. X ke 6 akere, and then y ke -4, ne?
Yes,
So
sir.
ko re mo re bonang x robia 6, why bona? So that's why they ke beile 6, and then mo re bonang y re ngwalang -4, why bona? So cause re substitutile y le x, no re nyaka that c value, why bona? So that's why ke re -4 is equal, half of 6 ke eng? Ke 3, ne? That's why I'm having 3 there. So why one? So remember, this type of an equation is what we call a linear equation. And you remember, most when we did our lesson, we said if you have a linear, that means you always want to have numbers on one side equals to letters on one side, or letters on one side equals to numbers on one side. That is why I'm moving this 3 to the other side so that I leave that letter on the other side. So it's more like you're having what is it? -4, -3. I want. So it ends up giving you -7. So now you've got your M and you've got your C there. Wayibona mos?
Yes, sir.
100%. Okay, last one. Who's got a question, or do we now move on to 3.3?
So I wanted to ask, like, let's say you leave your half in like a decimal, like 0.5, would the marker mark it correct?
They have to, honorable member. They have to, because it is a half. But most importantly, when you are dealing with functions, it is advisable that you write everything in a form of a fraction. So just make sure, Honorable Chantal, that where they did not say something like round off to whatever, leave your answers in a form of a fraction. But wherever they say correct to whatever decimal places, that means with confidence you can leave your answer as a decimal, which is rounded off correct to whatever. Happiness there, honorable member.
Yes, thank you, sir.
Okay, so now let's move on to 3.3. So I'm just going to remove all of that. Then let's see. Under 3.3, we've got some questions there where they say calculator. There, 3.3.1. Yes, says Bantu Bagiti. Very, very much important that you make sure that you first question, you answer it correctly. Imagine if you got that incorrectly, matter below, that means this is also going to be incorrect, possibly affecting other questions. I'm not sure what they say about a potato, but something, one potato rotten, the other potatoes, something of that. Hey, guys, if you don't get it, this is how I know that someone did not attend today's lesson. Okay, let's see. 3.3.1. The coordinates of C. The coordinates of C. This is how examiner tries to be smarter, where they indirectly want you to use that formula for the midpoint. If you guys remember, from the statement, they said from there to there is equals to from there to there. So that means this, which is what we have just calculated, it's actually the midpoint coordinates, the middle point coordinates. So it's more like this is what you are having. Point E having 6 and -4. You have that middle point being D having 0 and that. And then you also have that being point C. So can you guys see? You can say the middle point, its x value is equals to x of, let's say, C plus x of E, and you halve it into equal parts because they said that is equals to that. So remember, every time when you divide something by 2, it's more like you are cutting it into half. So let's see, you are then going to say a midpoint for the y value is going to be y of C plus y of E equals over. Then you now let's see. Hey, C is what we are looking for. That's why I'm going to write x of C there. But do I know x of, yes, x of E is 6 divided by 2. Remember, analytical geometry, a game of two things. This is what I meant when I said you will be given 1 point and an answer, or 2 points. In this case, we are given 1 point and an answer. What is an answer in that case? What is the x value of the midpoint? Is it not 0? So can you now see? You can maybe work out this one where you cross multiply. What is 0 times 2? Obviously, it's 0. So that means you're having that, which is equals to that. Then you take this to the other side. You end up having your x at point C being equals to -6. Remember, you just take this to the other side, it changes the sign, it becomes -6. Then you do the same there. What is y of C that we don't know, plus y of E, we know it, it's -4 over 2. What is the answer? It's -7. That times that, I think it's -14, which is equals to y of C. You have invisible 1 there. If you say that 1 times that, it gives you -4. Then you can take this to the other side. You end up having -14 plus 4, which is equals to y at C. So it's more like y at C, it's equals to -10. So that means the coordinates of C is actually -6 and -10. Most importantly, finally write your answer in that format, because that's how you represent the coordinates. I'm not sure. Am I losing some of you guys there, honorable members? I'm not sure if I'm losing you guys. Luyanda, am I not losing you?
No.
The Mayandiswa, are you sure you are satisfied with all of that? Denny, are we on the same page on that one? Am I breaking? I'm not sure if honorable members are getting. Leslie, that one, it was straightforward name. I think we can now
Yes, sir.
move on to the next question. So let's see. The next question says area of quadrilateral, let's say area of quadrilateral A, B, C, D. And they are going to give you 4 marks to just calculate that area. Jesus. I'm not sure. Anyone who would like to suggest how we can calculate that area? I think we did discuss it, but is there anyone who would like to just share their opinion in terms of how to calculate the area?
So I think you first find the area of the triangle.
The area of the triangle. Maybe let's see. Obviously, the area of a triangle will be equals to half, let's say, length times height, or the breadth, or whatever. So let's see. What do we know? What do we know regarding the length or the height and the breadth of that triangle?
So isn't it the length and the height should be perpendicular.
Okay, so this is what I was about to actually ask, to say what is the value of the length, what is the value of the height or the breadth. Okay, let me then remind you guys of something. Very, very much important that you remember this so that you can take some shortcuts. This is that Cartesian plane having the y, and we also have the x there. We have this point there, and this thing does something similar to that. And then we also have this thing doing something similar to that. Let's say we also have that. Do you guys realize that we can actually determine the length of B and D without using the distance formula? Do we not know what is the length from there to there? Do we not know?
One over two, sir.
1 over 2, 100%, which is a half. Let's say a half. Do we not know from there to there, Mzozozo? Do we not know that length or distance?
-7, sir.
So remember, because we talk about distance, we forget about the sign. At all the times, mathematically, when we talk about the distance or the length, you forget completely about the sign, just so that you can be able to know what is then the total distance of or length from that point to this point.
Seven and a half.
100%. So that means from there to there, Bantu Bakiti, it's 7 and a half. So that means what you might need is then from here up to there, so that you know that, okay, that's how you are therefore going to be able to know the area of a triangle. So what is that distance? So it obviously means you might need to perform a calculation there, which is where the distance formula comes in. But does it make sense, guys, before we even go deep? Do you guys have an idea of what we are doing there? Or are we losing some of you guys on that one? Silence. Guys, I'm not sure if you are still there, but or maybe are you guys busy calculating that distance? Obviously, to calculate that distance, you need the distance formula, which says d is equals to the square root of x2 minus x1 close plus, and then you've got your y2 minus y1 close that. What is that distance of CD?
Six.
Someone is saying 6. Is that correct? Is it everyone getting 6 for that one?
Eh,
I think I had a yes on that one. So now, let's see. That means you are having a half into. We just said that one is 7.5. And then you guys are saying this one is 6. Then, what is the area of that triangle?
22.5.
Someone is saying 22.5. So that means this is the area of a, let's say, this is the area of a, which triangle? Triangle A, B, C, and D. Yes, it is actually the area of triangle B, C, and D. I'm pretty much sure that it made sense to everyone. This is now examiner is going to catch you guys. Let me just allow you to make that mistake so that you might not forget it in future. Here comes a question. How are you then going to calculate the area of that one? How are you going to calculate the area of the remaining part? Because what we've just calculated is the area of that triangle.
Okay. Okay.
Someone is saying something. What are you saying there, honorable member? Now I see a homework. Shanti, this is what happens, honorable member. I do know very well why you guys are quiet. It's because possibly you assumed, based on what I said yesterday, I said it on purpose because I wanted to check if you guys do check and if you only go with what is being said. First thing first, this is how you approach this type of a question. You ask yourself this question to say, this remaining part, is it a rectangle or a square or none of above?
Above.
None of above, 100%. Obviously, you can see they've just said from there to there, it's equals to from there to there. But it doesn't mean from there to there is equals to there to there. Meaning, already, this is not a rectangle, it is not a square. Which possibly means from that point to this point, obviously it's not equals to that point to that point. I'm not sure if you guys understand that part before I even go deeper. Does it make sense to everyone what I've just explained there?
Sir, can you please repeat?
Okay, so I was saying, based on this information that we are having, if you remember, they said from there to there, it's equals to from there to there. So my question was, is this a rectangle? I mean, this remaining part, is it a rectangle, a square, or none of above? So honorable member said none of above because she realized that even though from there to there it's equals to from there to there, but it doesn't mean from there to there it's equals to from there to there. They could have said it to say from there to there it's equals to from there to there by showing somehow using those. And also you realize this is a vertical line, but this one, it's not a vertical line, but it is at that angle. So only if this one also was a vertical line, then you know this is equals to that, and that was going to be equals to that. So now, since we realize this is not a square, and again, this is not a rectangle. It's not a square, and again, it's not a rectangle. So that means you cannot use the formula by length times breadth or length squared. I'm not sure if honorable members understand that part. Silence. I'm not sure who asked for that, but does it make sense, honorable member?
Yes, sir.
Here comes a question. How are we then going to work it out? This is where I smell a homework. So just in case if you are thinking about it, this is where I say the moment you try to work out something and you find it difficult, your problems are not with calculating the area for that. Your problems are with you not understanding the characteristics of a trapezium. So that means this is what's going to happen. You guys will need to check in your study guides textbooks all the information regarding a trapezium. And then from there, you might come across a formula for calculating the area of that kind of a shape. So with that, try to use that formula, and I'm only going to give you a final answer and check if your final answer is the same as mine. So the final answer that you should get is 41.25 units squared. This is the final answer that you're going to get. And I'm telling you, if you go and check about a trapezium, you might also find a formula that you can use, of which is not the same as that approach. Then you need to try and apply that formula and check if you get that. Make sense, Bantu Bagiti? So that means out of this lesson, that's a homework that you should be doing from your side. Does it make sense? Voiswa, did you get your homework? Did you understand what you're supposed to do there?
Yes, sir.
100%. So that's how at varsity you will be trained. Every time you come across a problem, just know that your problem, it's not the problem that you're currently facing. Your problem is somewhere and you need to detect that problem, work on it, and I'm telling you, once you understand all that is related to your problems, you will then have a better understanding of how to approach such questions. Only when you struggle, that's when you may contact, and I will know that you have tried to check and this is what you have gathered, but you are still unable to use that. That's when I will then intervene. So let's see. Now we are, but wait, Chantel, do you now understand why you won't use the formula of a rectangle or a square?
Yes, I understand.
100%. So that means it was, of course, the correct approach to separate those. But most importantly, even though you have separated those, this is the shape that you made it to be a triangle. But this one, it's not that. Maybe let me try to explore something. Just hold on for a second. I want to check if what I'm thinking can also assist. This is what I'm thinking. If, for example, you want to make this a square, that means you might need to try and have a line which is perpendicular to that, which means you might need to have that type of a line forming a 90-degree there. Then you know this straight line is parallel to that, and also this is a right-angled triangle. Then that means what you were going to need, it is therefore, let's say if you use this point and that point, that means you already have that length. And then from there, you can use this and that to get that length. And then somehow you can still use theorem of Pythagoras to get this length. Then from there, you can easily calculate the area of that triangle. Then you have this square now. You already know that length. You can maybe just use these 2 points to calculate that length. Then you use that formula. So this is the type of thinking that you will need when you get to varsity. For every type of a shape that you see, you need to be seeing so many things there. I'm not sure if you guys understood what I was trying to explain there. Does it make sense though? Or you guys are lost on what I've just discussed? Does it make sense?
So it makes sense.
So that was just me trying to give you other options to say, under this chapter, you don't only have one type of a solution. You can still approach it in different ways. So also, when you practice, if you know what the final answer is, try to explore other options by using all the information that you know. So you now have two possible ways of working out that. But in the meantime, let's move on to the next question, being 3.4. So let's see. 3.4, they say if point K is the reflection of E in the y-axis. Sure. I've just explained this one to say when you reflect something in the y-axis, this is that point E there. You just take it from there and then you hammer it to the other side. Meaning, if you are having point E being X and Y, point E on this side as a reflection. If it's along the y-axis, it is X that changes to become a, what is it? A negative. But if it was reflecting about the x-axis, then you know it is the y that changes a sign. So that means this point E is actually going to come to this side. It's going to be above that point because that is where x, it is -6. So that means this point E, of which now it's given a name, it is not E prime, but it is now K. Then it means it is actually -6 and -4. So you can see the Y doesn't change. It goes as it is. It's only the X that changes a sign and it becomes a negative. So that means you have a K that you can connect it with C, forming a 90-degree angle there, because of this is a straight line. So it's more like you now have something looking like that, being a, let's say, E there having 6 and -4, and then you have your new point there being K being -6 and -4, and then you also have that C there being -6 and negative that. Obviously it's a right angled triangle. What I've just explained there, does it make sense, or is there someone who's got a question on that one?
Repeat again.
Matapelo, I couldn't hear you, honorable member.
Can you repeat again? I don't understand.
Okay, so let's see. Let's say, for example, maybe let me just use that same information there. So you are having C there, and then you are having E being that point there. So obviously E has got X and Y. So maybe as part of our notes, let's say maybe a reflection maybe about a Y axis. Then this is how you can represent it. You just say X and Y, it changes to -X and Y. Then reflection about the X axis. It starts being the original coordinates. Then what changes is actually that. You can just write down that as part of your notes. Maybe Matapelo, unmute your mic. Let's try to do it in a form of a dialogue. Let's see, what are we having for the coordinates of E? What are the coordinates of E, Matapelo?
It's 6
I'm
and
not
negative
able to. Yes, it's 6 and -4. Okay, so they are saying reflection about the y-axis. You agree, nay?
Yes.
So that means we pendula this thing about the y-axis. So can you see this point? It is somewhere there. So you take it from there and then you pendula it about the y-axis, and it's going to be there. So this is where that point it is going to be. Or if you don't know where it's going to land, this is where you use this thing. You tell me, Matapelo, if as the reflection about the y-axis and we are having this being those, what changes on these coordinates?
It will be -6 because it's changed and -4.
Yes, because it's the x that changes. So that means you are going to put a point where x is, let's say, -1, -2, -3, -4, -5, -6. Also where y it is, let's see, -1, -2, -3, -4. So can you see it's actually still along that point, which is somewhere there, and this point is given a name. What is the name of this point, Matapelo, this new point?
Okay.
Yeah, so this point, it is called K, which is -6 and -4. So can you see, this reflection, it reflects along that straight line there, because it is at where y is 4 or -4. And then also it lies directly above that point because they share the same x value. That is why I'm saying it forms a 90-degree angle there. So now you can still connect that, and then you are having a right angled triangle, which means whatever question that comes, you can still use what is it? You can still use trig ratios or theorem of Pythagoras. Does it make sense now, my prayer?
Yes, sir. Thanks.
Okay, 100%. So now, let's see. Now, examiner says, hey, we have indirectly answered a 3.4.1. I'm not sure if you guys are able to see. Yes, yes. How many? 2 marks. We have answered that question indirectly. I'm not sure if you guys are able to see. You just say K, it's -6 and -4, and it's based on this. So can you guys see? For example, if I had to give you a homework on this one and I said, what is the new coordinate of C? And you get confused, I wasn't going to then stress myself by explaining you to that. I was going to say, go to your textbook and learn about reflections. That's where your problems are, not there. Because once you learn this, then you realize it's going to be easy to answer that. So that means if you don't know about these, you won't be able to answer that question, which is the same approach that I'm explaining to you regarding your homework, to say your problems are not with the area. You know how to calculate the area. You know the formulas for calculating the areas, but your problems lies with you not understanding the characteristics of a trapezium. So now let's move on to the next question, which is 3.4.2, which says calculate the perimeter of triangle KEC. Let's see, KEC. Anyone who'd like to suggest how do we calculate the perimeter? Or what is the perimeter?
You add all sides.
100%. When it comes to the perimeter, you add all the sides. Do we know what is the value of that side? Do we know? Okay.
Can't we use distance formula?
Someone is suggesting we use the distance formula. Okay, that's a very good approach. Try to use the distance formula in the meantime and let me know what you get for that. Here comes a question. Do we know the length from this point to that point? Do we know? Silence
It's
in
K.
court. Silence in court. This is what I would like you guys to learn. Very, very much important to say. Sometimes you can easily do some of the other things. Let's see. We are having, let's say, 1, 2, 3, 4, 5, 6. -1, 2, 3, 4, 5, 6. And then let's say we're having -1, -2, 3, 4, 5, 6, 7, 8, 9, 10. They said this point is -1, -2, -3, -4, and then where that it is 6 there. This is that point E, and then it reflected to give us point K, which is still along 1, 2, 3, 4 along that -4, but where this is -6, so this is that point K. And then we know what this point is. It is -10 and that. Maybe let me write that and say this is -6 and -10. And then we know that this point E, it's actually what? X there, it is 4, and X, it is +6, 4 is that. And this is the one which is -6 and -4. Let's do that and say it passes there, and then we have this one there, and then -1, 2, 3, 4, 5, 6, 7. Yes, we remember that this one they were saying it cuts there at 7. Yes, let's say something similar to that. -1, 2, 3, 4, 5, 6, 7. Yes. Okay, this is what I would like you guys to learn. Guys, what is the distance from there to there? What is that distance? From there to there, without you calculating. I know we have done this before, where I show you how to know the length or distance by just using your Cartesian plane, having the x and the y axis. What is the length from there to there?
It's +6.
Positive 6.
Yes, it's 6. What is the length from there to there?
It's negative. It's 6 as
Yes, +6 because it's a length. So that means from there to there, we already know what that length is. What is that length?
it's 12 units.
12.
The length is going to be
12
12.
units. 100%. So what about from there to there? How are you going to then calculate that? So you're going to say, what is from there to there? What is that length?
10.
10.
10.
10, 100%. Then you can subtract from there to there. Then you know the remaining length. It's actually from there to there. Then what is that length?
1, 2, 3. 1, 2, 3, 4.
7.
Hmm?
7.
What is that length?
It's 6. It's 7 because it's 7.
Okay, let's see. If from there to there is 10, what is from there to there? What is from there
It's
to there?
10.
4 units.
6.
So 6 units.
6 units.
Order, honorable members. Honorable John Steinhazen, can you please take your seat? Order, honorable members.
So is unit 4?
7.
Order, honorable members. You are not going to disrespect the president. Otherwise, I'm going to call the security to take you out. Order. Okay. Chantal, on what point are you rising on, honorable member? Chantal is sleeping in parliament. Moleboge, on what point are you rising on, honorable member?
On getting the correct distance
Which is
from 0
origin.
to our C, it's 10. So from 0
Yes.
to it's -4, which is 4. So from 4 to 10, it's 6 units.
Yes. So
So
you
our
just say
distance
the
is
total
6.
length. The total length is 10. And then you want to subtract from there to there, which is what? Which is 4. So that means you're going to subtract
Yes.
that. That is why you're going to say 10 minus 4. And then the remaining is actually from there to there, which is what you're looking for. And you get 6. So that means this is 6. What is it? Units. 6 units. Yes. Do you guys agree with that honorable member on that one?
Yes, sir.
100%. Maybe anyone who doesn't understand how we got that one, so that we can quickly explain. But I think it's straightforward. I think that one, it was straightforward. So remember, guys, because this is a right angled triangle, only if it's a right angled triangle, that's when you can use theorem of Pythagoras to find the other side. So that honorable member who used the distance formula, let's check if we're getting what honorable member got. So that means it's going to be 12 squared, let's say, plus 6 squared. R is going to be the square root of that answer. So can you guys see that the formula for calculating the distance, it takes us back to the formula for calculating the distance, because you are having that x there, you are having that y there, which is being squared. So I'm pretty much sure that you guys now have an idea of how that formula for calculating the distance came about. So what are you then getting there? Let's see. A square root of 12 squared. What is it? What did you get there, honorable member?
4-2.
Hey, 4-2. Oh yes. So at this stage, Matapelo, if you get it in a form of a fraction, write it as a fraction or as a side, as that. You don't round it off as yet. Then you're going to then say the perimeter is actually 6 plus 12 plus 6 square root of 5. Then that's when you can add all of that. Let's see. 6 plus 12 plus 6 square root of 5. This is what I'm getting. 31,42. Here comes the question. Is it a unit squared or unit cubic?
It's just units.
Kanjani?
I'm
Is it
sure
not?
it's
Shanti, kanjani ntombo?
are we not so
Angikuthembi wena.
for
It's unit
perimeter?
squared.
You see now, someone is talking. They're saying it's unit squared.
I
Shanti,
don't think you
angikuthembi.
write anything
Can you
because
can you elaborate?
Elaborate on why I'm saying it's none.
What did you say? Did you say it's unit squared, unit cubed, or just units? What did you say?
I said it's just units because we are solving for perimeter, and perimeter is not squared. Squared is area, and then cubic is volume, if I'm not wrong.
100%. That's what I needed from you guys. So remember, Bantu Bagiti, what happens is, let's maybe make an assumption that this was a meter, and then this was that length meter, and also this one, it was 12 meter. So can you see what we actually did? It's more like we said perimeter will be equals to 6 meter plus 12 meter plus 6 square root of 5 meter. That is why whatever that we're going to get is going to be just in meters. You only get meters squared if you are multiplying, for example, that 6 meter times 12 meter. Where is that times that, and then it's whatever, multiplying the same basis, you add the exponent. So it's more like m to the power m plus that, and then that's why it makes it m squared. If it's cubed, that is because, for example, you're saying 2 meter times 2 meter times another 2 meters. So can you see you have 3 m's, which makes it a cubic meter. So here, because we are not dealing with millimeters, centimeters, meters, or kilometers, it's just a unit. So that is why in the end you're just going to say unit. So you will need to remember this at varsity to say, because one thing for sure, when you get to varsity, somehow you will be calculating perimeter. It's going to be as easy as that, but it will be asked in a very tricky way. You just need to remember that when coming to the perimeter, is just whatever unit that you are given. Does it make sense, honorable member? Iyenza umqondo le nto le.
Yes.
100%. So now, quickly, last question. So they are saying the size of angle C in triangle K, C, and E. So it seems like we are still on that same triangle. Yes, we are still on that same right-angled triangle. And this is the angle that they want you to calculate. Let's maybe call it angle theta. So anyone who would like to suggest how we are going to work out that one? I think I might also give this one to you as a homework in case if it's silence in court. Any suggestions on that one? Any suggestions on that one? Silence in court. I'm not sure if you guys are still thinking that side, but this is our last question, of which if you'd like to give you guys a hint, just let me know. That's if it's difficult.
Get trig. I was saying, can't we use trig because we already found the lengths of the sides? So to find C, we can just...
But how do you know that you can use trig? What gives you the confidence to say you can use trig, and which trig ratio is suitable?
I think we can use sine and say opposite over hypotenuse because we already found the perimeter of the triangle. So we can just like substitute.
Very quickly, this is what I'm going to say. Maybe let me remove that and also remove this. So when it comes to maths, based on the reasoning, that's how I'm able to notice that you understand to a certain extent. But thanks very much, the Mavui Swaz, for giving that input, because it's going to help everyone, because I'm about to explain to you something. This is a triangle, And this one is a triangle, but it is special. What makes it to be special? It is because of that sign. I think this could be what isosceles and also scalene. I think, yeah, those type of triangles. But this one that has that is what we call a right-angled triangle. That's what this one is called. This one is not a right-angled triangle, but it does look like a right-angled triangle. But because it does not have that, then it is not a right-angled triangle. So only if you have a right-angled triangle, you can use these four things: either sine, tan, or cos. And lastly, this thing called theorem of Pythagoras. These are the only things that you can apply to a right-angled triangle. A triangle similar to this one, that's where you use the sine rule and the cosine rule, of which I'm going to teach you those as time goes on. So that means you've got two types of triangles, one being a right-angled triangle and another one being just a triangle. So when you are dealing with just a triangle, you either use the sine rule or the cosine rule. But when you are dealing with a right-angled triangle, you don't use the sine and the cosine rule, but you use the trigonometric ratios. So these three things are what we call the trigonometric ratios. Let's see. We have sine, cos, we have tan. Trig ratios. There are what we call the reciprocals, which are the which are the inverses of the trig ratios. I'm sure you guys remember cosec, sec, and cot. If you don't, then it's something that you're going to learn. And we say these are the cousins of the trigonometric ratios. If you want to know whose cousin is who, then you say you look at those and you concentrate on letter number 3. Can you see COS? Then this S, it means is for sine. So that means sine is the cousin of cosec. Then you go to sec. What is the letter number? Can you see letter number 3, C? C, cos. That means this is the cousin of that one. Let's see, letter number 3 is T. T for tan. So that means we have cosec, we have, cot, then we have sec. These are what we call the trig ratios. These are what we call the reciprocals. So now, in this case, when I said, how do you know that you can use a trig ratio? It's not because of the perimeter, but it's simply because you see that, which means this is a right-angled triangle, and you are therefore allowed to use the trig ratio. And also, how did you know that you can use this to calculate that length? It's because you saw that a 90-degree sign. That is why I did not straight away use the distance formula, but I just used that. So that's how you know if you must use a trig ratio. But if they don't show you that and they don't tell you that it's a right angle triangle, never assume. If you are not told, if you don't see that, never assume. Just say it's just a triangle. So now that it is a right angled triangle, I'm going to give you a very important tip, honorable members. Use a trig ratio that will allow you to use the value of 12 and also that value of 6. Why not the one that will force you to use that? It is because this one, what was inside? I think it was 5, but whatever that it was, this one you just calculated it using that. What if you made something wrong there? It was going to affect your answer. So use a trig ratio that will allow you to use the original information, or the information that you easily got. But this one, can you see, you have done a rounding there. If you remember, someone could have got that and written it as a decimal, and they use this decimal to calculate that angle, and they don't get an accurate answer. So I think you can easily use tan there and say tan, that angle, it's going to be opposite. What is opposite that? It is that, over adjacent being that. Then your angle already, it's equals to that. What is that? I think that is 2. Then you get an answer there. I'm not sure if it makes sense to everyone. What I've just explained, does it make sense to everyone? Maybe let's see. Did I substitute correctly there? I think I did. But does it make sense to everyone? Bantu bakithi.
Yes, it makes sense.
Degrees, 100%. I did receive your responses on that one. So, ladies and gentlemen, I'm about to sign out. I'm not sure if there's anyone who's got a question before I sign out. Anyone who's got a question? Or did all make sense? Mzozozo, it is that time, honorable member, but Utulile, I'm not sure if we are together, Mzozozo. You
Say
never said a thing
I'm with
today,
you.
Mzozozo. Okay. Libandla la kaNkulunkulu lithulile. Do you allow me to sign out, Mzozozo? Maybe let me say the code for today. You can either comment distance, midpoint, or gradient. That will be the comment. I mean the code for today's lesson. So just comment with any of those. You can choose distance, midpoint, or a gradient. So, ladies and gentlemen, my name is Desmond. You guys have a very good night, and I'm out.